Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem based on the concepts of limits application. So as per the given problem, a construction worker drops a bolt while working on a high-rise building 320 meters above the ground. After t seconds, the bolt has fallen a distance of s meters where s at t equals 320 minus 5t squared and t is between 0 and 8 including 0 and 8. So let's start with part A. So in part A, we have to calculate the average velocity during the first second, the third second and eighth second. Now let's start with the first second. So the average velocity, as you may know, is the velocity we calculate over a period of time. So the average velocity over the first second or during the first second will be the change in velocity from the beginning of time to the end of first second. So basically the change in velocity from t equals 0 to t equals 1. So that's a very important concept we need to understand and memorize because we have to calculate the average velocity during the first second. So basically just the beginning of that first second to the end of that first second. So here we'll have to use the formula for average velocity. So the formula for average velocity, so I'm using AV for average velocity. So we are given the position function here. So it will be s at 1 minus s at 0 over 1 minus 0. So basically the final position minus the initial position over change in time. So we have to calculate s at 1 and s at 0 from the given position function. So we can calculate here on the side. So s at 1 will be equal to, so we'll sub in t as 1 in this given position function. So it will be 320 minus 5 times 1 squared. So s at 1 will be equal to 320 minus, so 5 times, so 1 square is equal to 1, so 5 times 1 will be just 5. So s at 1 will be equal to 315. Now we also have to calculate s at 0, so we'll sub in t as 0 in this given function. So we'll sub in t as 0, so s at 0 will be equal to 320 minus 5 times 0 squared. So we get s at 0 equals 320 minus, so 0 square is 0 and 5 times 0 is 0. So s at 0 is equal to 320. So we'll sub in these values in this average velocity formula. So it'll be 315 minus 320 over, now in the denominator 1 minus 0 is equal to 1. So it'll just be equal to negative 5 because 315 minus 320 is negative 5 and divided by 1. Now since we are given the units for distance and time, we'll have to include those units in this answer. So it will be meters per second. So this should be the final answer for the average velocity during the first second. So now we can do this calculation for the third second. So basically for the second part we'll have to do t equals 2 to t equals 3. So the formula will be average velocity equals, so the position function at 3 minus the position function at 2 over 3 minus 2. Now we have to find out what the position functions are at 3 and 2. So if we sub in t as 3 in the position function, we get 320 minus 5 times 3 squared. So now we can evaluate the square term. So we get 320 minus 5 times 9. And now in the next step, we can do 5 times 9, which is 45. And now we can do the subtraction. So S at 3 is equal to 275. So now we have to calculate S at 2. So we'll sub in T as 2 in the given position function. So it'll be 320 minus 5 times 2 squared. Now we have to evaluate it. So 320 minus 5 times 4. So S at 2 equals 320 minus 20. So S at 2 will be equal to 300. So now we can sub in these values in this formula. So the average velocity will be equal to, so 275 minus 300, and 3 minus 2 is equal to 1. So this is equal to negative 25, and the unit will be meters per second. So this is the average velocity during the third second. So now we can continue with the 8th second. So we can continue here. So in this case, the average velocity has to be calculated from the beginning of the 8th second, which will be the end of the 7th second, to the end of the 8th second. So that is from t equals 7 to t equals 8. So the setup will be, so average velocity equals s at 8 minus s at 7 over 8 minus 7. So now we have to calculate the values of s at 8 and s at 7 from this given function. So let's start with s at 8. So we'll sub in t as 8 in this function. So 320 minus 5 times 8 squared. So s at 8 equals 320 minus 5 times 64. And 5 times 64 is equal to 320. So s at 8 will be equal to 320 minus 320 equals 0. Now we have to calculate s at 7. So we'll sub in t as 7. So 320 minus 5 times 7 squared. So now we can evaluate it. So s at 7 will be equal to 320. So 5 times 7 square will be equal to 245. And then we can do 320 minus 245 equals 75. So now we can sub in these values in this average velocity setup. So S at 8 is 0 minus 75 over 1. So this will just be equal to negative 75, and the unit is meters per second. So this should be the final answer for the average velocity during the 8th second. Now we can do part B. So in part B, we have to calculate the average velocity over the time interval 3 to 8 seconds. So we'll use the same setup. So average velocity equals, so s at 8 minus s at 3 over 8 minus 3. Now we have already done these calculations here. So we know that s at 8 is equal to 0 minus, and we calculated s at 3 in the middle part. So s at 3 is equal to 275. So 275 over 5. And now we can simplify this. So negative 275 over 5. So I got negative 55. meters per second. So that's the average velocity from 3 to 8 seconds. So now we can work on part C. So I'll use a different color here. Now in part C, we have to calculate the velocity at 2 seconds. Now this is instantaneous velocity because we are calculating velocity at a point in time, not over a period of time. So we'll use the formula for calculating the velocity from the position function, and we can calculate that as, so velocity at any point A can be calculated as, so limit h approaches 0. So we'll use the limit formula using the difference quotient setup. So the position function at A plus h minus the position function at A over h. Now in this case, we have to calculate the velocity at 2 seconds. So the A value is equal to 2. So the S at 2 is equal to 300. So S at 2 plus H. So we'll sub in T as 2 plus H in this given expression. So we get 320 minus 5 times 2 plus H squared. Now we can expand this square expression. So we get 320 minus 5 times 2 plus h. So we can expand the square. 2 plus h times 2 plus h. And now we can simplify it. So 2 plus h becomes, so 320. Now we have to use the FOIL method. So now we distribute the terms. So we have to do 2 times 2, then 2 times h, then h times 2, and then h times h. So we get 4, then we get 2h, and 2h will be 4h plus h squared. Now we can distribute the 5 into the parentheses. So we get s at 2 plus h is equal to 320 minus 20 minus 20h minus 5h squared. And now we can combine like terms. So s at 2 plus h is equal to 300 minus 20h minus 5h squared. So this is the expression for s at 2 plus h we should use in the formula for instantaneous velocity. So we get, so v at a is equal to, so we start with limit h approaches 0. So s at a plus h is, so 300 minus 20h minus 5h squared, and then minus s at a, which is 300 over 8. Now we can cancel out the 300. So now we'll be left with, so v at a, so I'll just start here. So v at a, or now here, so instead of a, we should also use 2. So it's not v at a anymore. So v at 2 equals, so limit h approaches 0. So negative 20h minus 5h squared over h. We have to cancel out the h in the denominator, because if we apply the limit, then the denominator will become equal to 0. So that way the expression will become undefined. So we can factor out an h from the numerator. So if we do that, we get negative 20 minus 5h over h. So the h's will cancel each other out. And now we can apply the limit. So it will be negative 20 minus 5 times 0, which will be equal to just negative 20 meters per second. So this should be the velocity of the bolt at 2 seconds. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.